Good evening, everyone. Hope I'm audible to everyone.
Yes.
Can anyone? Yeah. Thank you, sir. Good evening and a warm welcome to all. I'm Dr. Juhi Yasmin, Assistant Professor of Communicative English, Department of CSE, AI and ML, and Cybersecurity, Faculty of Engineering and Technology at Jain University. I'm here to welcome you all to today's Industry Connect session. Today's session is on cybersecurity with special reference to threat modeling, MS using MS threat modeling tool. Today we have with us and esteemed guest speaker, Mr. Nadeem Najeeb. Currently, he is working with Philips Healthcare as a product security specialist. He has earned his B.Tech from Kerala University in 2015 and his master's in cyber forensics and IT security from the University of Madras in the year 2019. He is a certified information system security professional. So, on behalf of the entire Jain family, I would like to extend a warm welcome to you and would like to thank you for taking out your precious hour to be spent with us. Today's audience is students of B.Tech Cybersecurity and BCA Cybersecurity students, as well as our faculty members of the same department. So, now is over to you, sir. Please start the session.
Thank you, Juhi ma'am, for the warm welcome and good afternoon, everyone. How is your Saturday going on? So this session, I need everyone to be very interactive. This would be an interesting session, and this would be a kind of a niche session. This is particularly this skill set you can only achieve while you are working in an industry. So I'm giving you that opportunity to learn from your early days itself as a student. So this session, if you carefully listen to this session and interacting with me on this session, then you can add a great point in your resume while you are attending for a job interview later in your career. Okay, so I need everyone to be very very active. Whatever the answer, it's fine. So you have to be active and you have to give me the inputs. That input takes me to the session. Okay, so let me present you my screen. As Juhima mentioned, so our topic for the day is threat modeling. And threat modeling, how we are going to do threat modeling with the help of a tool called Microsoft Threat Modeler. So this session would be more of like a interactive session with some hands-on training on the tool. Okay, so guys, please be very very careful, listen to the topic, try to understand. Okay, you are gaining a skill. I'm just giving you the heads up that you are gaining a skill within your college life itself. Okay, so be with me, give your inputs, will make the session very very interactive. Okay, so before we jump into the hands-on, I'll just give you some introduction on what exactly is threat modeling and some nomenclature and basics of the threat modeling. Okay, just give me a second. Let me present it. Hope everyone would be okay. Give me a thumbs up or okay from your side. Then I'll start. I need your voice here, guys.
Okay, sir.
Yeah, great. Okay. Let's try to first understand what exactly is threat modeling. Okay, so from the name itself, you can identify that threat modeling is a kind of a process where you can identify the threats and model that threat into specific categories, right? Okay, so basically, threat modeling is a very structured process where we identify the security requirements. Okay, we'll try to understand what are the vulnerabilities in a system. Okay, what are the risks that can be happen when these vulnerabilities get materialized. Okay, and what can be the remediations or the controls which we can put in place to triage the vulnerability. Okay, then where do we do a threat modeling? Okay, that is the first thing we need to understand. So while creating any application, we have a very good framework which starts from the design phase itself. Like first we understand the requirement. Okay, so in the session, in the interactive session, we will be trying all these things. So just try to understand what I'm trying to say now. So first, if we want to develop any application, okay, in the IT space, we have to first have a set of logical ideas, right? What exactly this application has to do, what is the purpose of this application, what kind of data will be storing, okay, how basically the application has to be, okay, what kind of architecture it has to be folds into. All those things uh, we will understand in the requirement phase. Okay, so immediately after the requirements are developed, the designing team starts developing a prototype of the application, basically just a small working small working element of that application. Okay, that is called the prototype. That phase itself we start the threat modeling. Okay, so the approach of threat modeling, or the purpose of the threat modeling, is to identify in the early phases of development the threats in the application. And if we identify such kind of threats in the application, and then we started remediating those risks or the threats in the upcoming development phase, then what happens is we can reduce the cost of building that application and spending more money on the security part. Okay, so what are the artifacts, or what are the outcomes of a threat modeling is, we'll understand the abstraction of the system, which basically means a data flow diagram or a high level architecture of the application that we'll understood through the threat model. Then what are the potential attackers, or like basically who can attack the system from inside or outside, who can attack the system, those kind of information can be obtained from the threat model. Okay, and also we can understand which categories of threats can be possible to this solution. Okay, so as I mentioned, every application which has to be developed in a structured format has to go through a framework of development, which is called the software development lifecycle, which you will learn in your upcoming uh, portions in the syllabus, or you might have learned it. Okay, so in this SDLC, or the software development life cycle, there are basically 5 steps, in which the first step, as I mentioned, we try to understand the requirements of the application. Okay, once the requirements are fixed, then we'll move to the design phase, where the designers develop a prototype. Okay, once the prototype is completed, we move to the development, where the developers code the application. Okay, once the code is done, we do the testing of the application, right? Once the testing everything is completed and the application is safe, then we will host the application, which is called the deployment of the application. Okay, so the threat modeling part which we are focusing here is majority or the predominantly done in the design phase of the software development lifecycle. Okay, that is what this picture or the diagram is representing. Okay, so the other security test which we might have heard, or some of you might have aware of, like the pen testing, the code analysis, all these are done after the threat modeling only. Okay, so as a security analyst, you need to start from the scratch, where you need to know what exactly is threat modeling. Then only if you want to progress into your career more into the pen testing, all these things, it would be helpful for you by understanding from which angles the threats can come. Okay, so just giving you some two liners on what threat is, what vulnerability is, what risk. This is just a brushing up of your knowledge. Okay, so threat is, as everyone knows, something unwanted event or some unwanted alarms, right? That is called threat. Anything which is raised out of the context or unexpected way, then it can be considered as a threat. It's a negative event. Okay, vulnerability is a weakness. Okay, just in the layman terms, it is a weakness in the application. And risk is, if the threat and the vulnerability can be exposed, if the vulnerability can be exposed with the help of a threat, then it comes to the risk. Okay, that impact is called the risk. Okay, just refresh your thoughts on this. Okay, now I'm just going to give you an understanding of how does threat modeling works. Okay, so in the threat modeling section, we try to understand few things. Okay, the one is the threat agents. Okay, so while doing the threat modeling, we need to keep this in mind that okay, from where the threats can happen, whether this can be happen from an inside the organization or whether it can happen from the outside of the organization. Okay, or it can be from a process or a code itself. A threat can be initiated. All these things you have to be understand, and this is how you think from a attacker perspective or a threat modeler perspective when you do a threat modeling. Okay, so in the upcoming session where once we do the hands on, you people has to think in that direction. You have to give me the inputs. Okay, then the second part of it, like once we identify the attack surface or basically from where the attacks can be happen, then you have to think on the direction that how much damage they can process, so those attacks can process to the application. Okay, so why we need this is while we come to a conclusion of identifying a threat and converting it to a risk which has to be presented to the management or the which has to be presented to the developers. Okay, to make them aware that these kind of risks are there in the application, then you have to tell them what is the severity. Okay, so there might be severity like high, medium, low, all these things you have to understand. Okay, so think from that angle how much damage it can be made if an attack happens. Okay, then the third part is the understanding and analyzing the architecture. Okay, so while doing the threat modeling, we need to understand the architecture in depth. We have to ask a lot of questions to the architects. We have to understand how this application works and basically how the data is flowing. All those things we have to consider in the threat modeling phase while we are performing a threat modeling or we are finding the threats. Basically, the person who does threat modeling, his intention is to find the maximum number of threats in that particular design. Okay, it has to be kind of a like a challenge where you have to show them that okay, this design is not perfect. You have to rework on the design with the security involved in it. Okay, so basically in the industry there are two approaches used to do a threat modeling. Okay, one is the checklist based approach. The second one is the non checklist based approaches. Okay, checklist based approach means there will be a set of questions, okay, based on the organization's policy or the standards. Okay, so while we design an architecture there are a lot of things to be considered. Okay, so any architects working in an organization, they have to align with the organization policy and standards. They cannot design any architecture wherever, whichever they like. Okay, it has to follow different kinds of protocols or the standards. Okay, so in that we will develop the security testers. We'll develop certain checklist, basically like asking them questions on different controls which we have, like the user access controls, the firewalls, all these kind of controls we consider in place, like the network controls, the database controls, and asking them questions and trying to get answer on our solution. Okay, then trying to find the risk in that answers. Okay, or the risk in that architecture which they are going to develop. Okay, the second approach is the non checklist based approach, where we do a kind of a brainstorming or a discussion kind of or an interview kind of approach with the architects or the program managers to understand what exactly they are planning to build and what are the controls they have in mind while designing this software or a application. Okay, so based on these two approaches, the outcomes are basically a diagram, which is, as I mentioned, the data flow diagram that we will be drawing in the coming session. Okay, Then identifying the threats. Okay, so we'll come up with some list of threats that, okay, if this is not there, then this kind of threats would be there. Yes, we'll do that. Okay, then mitigate. Okay, mitigate means after identifying this risks or threats, we have to also recommend them what is the best practice which they can be followed to reduce the risk. That is called the mitigation. Okay, then validate is we need to ensure that all these mitigations has properly followed, and in each step of the development, the risk has been reduced, and ultimately at the end of the development there should be a minimal list of risks only. Okay, so these are like a very high level understanding of threat modeling. Okay, then while we doing threat modeling, we need to classify these threats which we identified into certain categories of generally identified threats. Okay, so there we use a framework called the stride. Okay, stride is a framework which is throughout the industry used, and this is developed by the Microsoft. Okay, so stride means basically spoofing identity. The S stands for the spoofing. Okay, spoofing basically means uh, acting as an another person, or pretending to be someone. Okay, then or something. So this basically affects the authentication part of the application, where we ensure that the right person is logging into the application. Okay, there are situations where we can spoof and we can fake, basically, right? We can do proxy kind of things. We can fake and we can get access to the application. Okay, then tampering with the data, which is the T stands for, basically it affects the integrity of the data, where the data gets modified in the disk network or wherever it is used. Okay, then reputation means that it's a false claim, where you are claiming that this has not done by me, but has to be done by someone else, something you did wrong and you are putting blame on someone else. That is called the reputation part. Okay, so it violates the property of non-reputation, like not sticking to the exact thing which you have done. Okay, then information disclosure, basically the confidentiality part of the information security is exposed. Okay, then D stands for the denial of service, where the application is not available to the end user, like the availability has impacted. Okay, and E is the elevation of privileges, where the attacker gets a minimum privilege first, and then he elevated the privilege, which means basically he exploited another threat in the application, or vulnerability, sorry, he exploited vulnerability in the application through a threat agent and or a threat attack vector, and then he got the next level of privilege like an admin. Okay, that is called the elevation of privilege. So basically whatever risk we find, that we have to categorize into this tried category, and we have to represent it to the management, so that they can properly take action, or they can put controls on the application around it. Because these factors like authentication, integrity, reputation, confidentiality, availability, all this authorization, all these things has different kind of controls. Like authentication, we have the multi-factor authentication, right? If a single factor authentication is only used, we can enhance the security by adding the multi-factor authentication by getting an OTP based login. Okay, integrity, we can add uh, data encryption on top of the data. Okay, then non-reputation, we can put digital certificates or SSL based certificates. Okay, confidentiality also, again encryption kind of mechanisms can be put. For availability, we can have multiple zones or backups to have our data secure. Authorization, we can put access control or role based access in the application, so that only the correct or the authorized person can basically get the access to the application. Okay, all these things has to be considered while we identifying the threat and categorizing the threat. Okay, into which category it falls to. Okay, so the next step is this step is very very important. Okay, while we do a threat modeling, we have to first identify the assets. Okay, so what asset means is, suppose if we are creating an application, I'm just giving a hint. So we are giving an creating an application of an e-commerce. Okay, so basically the assets of that e-commerce is the users. First is the users also is an asset to the organization. Okay, so people are the assets. Then hardware assets would be there, like the servers, the web servers, the databases, okay, the network, okay, routers, everything are another hardware assets, hardware based assets. Software based assets like operating systems in that hardwares, or any application which supports the operational part, that is an asset. Okay, those kinds are the assets of that architecture, okay, or the application. Then the attack surface analysis is the second step. So attack surface analysis means we need to identify which are the endpoints or the entry gates where the attackers can attack the application. Okay, that is the attack surface analysis. So just giving an example of if you have visited Amazon or Flipkart, then there is a search bar, you can enter the uh, products, right? So if you try to enter a malicious script into the uh, search bar, if it is accepting, then it is a attack surface. Okay, for that application it is an entry point. Okay, like that multiple entry points would be there. We'll come to that. Okay, we'll identify in our example. Then the attack vectors are like what tool or what exactly what aid you are using to attack the application, like the malicious script I mentioned, or are you using any tools to scan the open ports and trying to uh, ping that open port to get some information. Okay, all these things are the attack vectors. Then the next step is we analyze the first three steps. We analyze in the analysis phase. Okay, once we identify the threats, we analyze like how this can be exploited and what is the impact to that. Okay, based on that we prioritize the threat, whether it's a high, medium, or a low. Okay, and based on that prioritization we put the controls to the application. Okay, that's how a threat modeling is performed. So before we begin to the threat modeling hands on, we need to know few basic things. Okay, one is the nomenclature. It's not the nomenclature, it's like the definition and the shapes basically, which we use in the diagrams. Okay, so basically if you have developed data flow diagrams or algorithms and flow diagrams, basically there should be some kind of structures you have to use, right? The diamond boxes used for the decision, the oval kind of box you have to use for the process, the start of the data flow diagrams and all. Okay, so that kind of structure also is there in the uh, diagram which we represent here as part of the threat modeling. Okay, so every process should be mentioned as part in the application as a, in the architecture basically as a circle. Okay, the data store has to be represented by this way, the two parallel lines. Okay, otherwise some tools they might have the database database icon, okay, like the cylinder. Then external entity means anything outside the network could be represented by a square box, and all the data flows has to be mentioned as arrows. It depends on whether it is a two-way communication or a one-way communication. The arrows has to be in both the directions. Okay, then the trust boundaries has to be defined in a dotted representation of whether it should be a rectangle or a square kind of, or whether it should be a arch kind of or a plain line kind of. Okay, so these are the basic things you need to consider while we do a hands-on. Okay, now we are going to design a secure e-commerce website, and we are going to perform the threat modeling part of it. Okay, so guys, you can unmute yourself. You can ask me doubt if you have anything till this, because we are going to be a very interesting session from now. Any doubts, any concerns? Okay, I'm taking it as a no. But now, from now onwards, I have to get your inputs. Okay, based on that only, I am going to perform a threat modeling. Okay. Okay, so somebody can help me to explain what exactly the flow of a e-commerce website. Okay, just in layman terms, like what do you do when you go to a e-commerce website? Just somebody unmute yourself and explain me. Just in 2 to 3 sentences, that would be enough. Not too much in depth. We can explain me in a very high level. So based on that, we can come into an architecture. I'll help you on that. Who is a smart guy who can help me there? Hello, hello. Can somebody help me here, guys? Are you hearing me?
Yes, sir, you're audible.
Then somebody has to unmute and explain me how a e-commerce website works, or like what is the flow. What do you see when you go to any e-commerce website? If you guys are not unmuting, then I'll call your name and you have to explain me. Guys, let's make it interactive. Come on. Can somebody? Okay, then I will do it. Okay. So basically, once we think of a e-commerce website, there are few things, right? This e-commerce website can be accessed from any devices, like whether it's a mobile or a web-based application. Okay. Then once we visit the website, we have the option to browse different products. We can add the products. Okay. Then we can add the product into a cart and we can purchase it. Okay, with the help of a payment gateway. Okay. Then the other thing is, before we need to purchase, we have to create a user account in the application, right? Since application, then we have to give our details. Okay, all these details has to be stored in a database. Okay, so this database and these data, and how we trust the website, we have to ensure that the website is using a proper https based connection. If I'm going into the architecture, okay, we will check the um, diagrams. We will check basically the what do you call, the ssl kind of things are there. Okay, so I'm just going to one website, so we'll ensure that this website is connection is secure. Okay. Also we ensure that there are option to log out, all these things, login, all these pages are there, and then only we'll purchase the application, right? So with this context, I'm going to draw an architecture. So somebody give me an uh, work, or basically once you started working in the industry, am my screen visible to you?
Yes, sir.
Am I presenting? Okay. Okay, so while you start working, there might be your boss or someone else who will come and say that, see, we are going to develop an e-commerce website, or we are going to develop a product. So please perform a threat modeling. These are the requirements. As I mentioned, these are the functionalities. Okay, you have to do a threat modeling. You have to come up with the threats. Okay, as security consultants, we have to do this kind of activity if you are going into a profile of a threat modeling. So So for this purpose, I am using basically the Microsoft Threat Modeler tool, which can be downloaded easily from the Microsoft website. Okay, just Google it like Microsoft Threat Modeling tool, you will get this page. Okay, you can come here and you can download this tool. It's a very lightweight tool. Once you install the tool, you will get some screen like this if you open the tool. Okay, then the first thing what we have to do is, since we are starting from the beginning, we have to click on create a model. Okay, so I'm just giving a overall picture of this tool. So this is our workspace. It is similar to a paint tool, you can consider. Okay, this is our workspace. Okay, this section will be generated once we have the components and the risks which has to be presented here. Okay, once we complete the threat modeling. So in the stencils part, you can see like different components which we use normally in the architecture diagrams. Okay, so as I mentioned, our project is to create a secure e-commerce website. Okay, so for that, first once we think from the a normal user perspective, like how a website can be used and what are the components of it, we have to first include a browser, right, from where the application can be um, used. Okay, so this application has two interfaces basically. One is the browser. Okay, just drag and drop it here. Okay, you can freely move like this. Okay, the next part is the mobile client. Okay, like the mobile apps which we use in our day-to-day life. Okay, fine. Okay, we have two components. Okay, so now the thing is, we have to think like an architect. Okay, what happens once the users browse the website? Okay, so can anybody help me, or can anybody explain how a website works, or what happens when you type www.google.com in your um, browser? This is very important question. You have to note it down while you go for any interview with respect to security. This question can be expected. What happens when you type www.google.com in your browser? Okay, do you guys know what happens exactly in the backend, how this Google page is displayed to you? Anybody knows it? Okay, I'll tell you. Okay, so after that we can go into the next phase. Okay, so what happens when you enter any URL into the browser? Okay, immediately the browser sends that request via API, or this URL is converted into an IP address in the backend, and it reaches to the DNS server, domain name server. Okay, the domain name server has the details of where this particular IP address is hosted. Okay, then the DNS sends the request to the data center where the application is hosted, basically the Google page or whatever the page you are trying to search is hosted. That's how it works. Okay, in a simple term. Okay, so here also same happens. Like, what happens if the user types the URL, or from a mobile application, if you try to uh, access a website, what happens is basically the connection is routed to the DNS. From there, the connection is sent to a web server, right? So I'm not here mentioning the DNS, all these parts, but the next part is somewhere there is a web server hosted with the requested web page in a some data center around the world. Okay, so here we can think that this application is hosting in an Azure environment. Okay, so I'm just creating a data center. Though this generic trust boundary is something that anyone can trust. Okay, like it's kind of a corporate environment, you can think. Okay, so in that Azure, this is our organization, we can mark it as like my org. Okay, in the organization I have hosted a web server where my web pages, landing pages are hosted. Okay, so the next step, what happens once the request reaches the web server? First it checks for whether the request is okay originating from a right user. Okay, okay, so think of the scenario like this: application requires the authenticated user to access. Okay, or you are just signing to this application. Okay, then what happens is this application checks the authentication part of the user. So for that we have a component called Azure Active Directory. Okay, so Azure Active Directory is the identity provider here. Okay, this might be a bit unfamiliar for you. Just giving a heads up that in a layman term, you can think that once you enter your password into the laptop, common laptop or a normal laptop, what happens is the password is stored somewhere in the hard disk, right? So that is accessed. But in the web applications, these authentication happens in a different stages, and for that we can use this particular Azure Active Directory, or basically the Microsoft Active Directory. It is an identity provider, basically we say. Okay, identity means our username, password, all these things can be securely managed through this Active Directory component. Okay, then what else is there? Active Directories, you can consider that there are different kinds of enterprise objects, user management, all these things happen here. Okay, then this web API is there, that web server is there. Then after that, what would you see? You will have a database, right? Where in the database you store the data related to the applications. Okay, then this database has to communicate to the web servers. Okay, then one more thing I need to add here is the application server. So basically in a three-tier architecture, or basically an application, just consider any application, there would be the web server first. Okay, the web server receives the HTTPS request or HTTP based request, and it displays the web pages. Okay, in the back end, how the application works, the logic of the application is stored or developed in the application server. Okay, in the application server, the logic is developed, and any request from the web application has to be processed. It has to be sent to the application server, and the application server responds with the response to the web server. Okay, so here it is the web application server. Okay, I can just mention it as web application server. Okay, then a database is here which holds the data. Okay, then for a security part, we can add a key vault where we store the keys for the encryption and decryption part. Okay, so I'm just trying to find a key vault. Okay. This particular component, or this might be a server, or the server with an application hosted on it, that holds the uh, s- sorry, that holds the key uh, with the where we encrypt the database, like with that key which we encrypt the database. Okay, so these are basically the components. Now we have to establish a connection to all these components. Okay, before that, think from this perspective. This is the organization. All these components are hosted within a trusted environment in the organization. Okay, then Outside the organization, what is there? It is a untrusted space, right? It is the public network. Okay, this red line represent that organization is protected with the help of a firewall. Okay, that is called the trusted boundary. Okay, now outside this trusted boundary, there is a internet boundary, right? Where all the attacks, everything can be happen there. It's a untrusted network. Okay, that is represented through this arch kind of diagram. Okay, so what we are trying to protect here, or what the intention of threat modeling, as I mentioned, we have to protect the assets of the organization, right? So the assets are the people inside their data, this web servers, all these things, or whatever hosted or whatever inside this rectangle boundary or the trusted boundary within the firewall perimeter has to be protected from the external internet boundary. Okay, that is the intention. Okay, this is internet. Okay, now the mobile or the users has to first connect to the web servers, right? For connecting, we can use this request. Okay, so from here, a request is sent to this browser. Okay, same happens with here also. Okay, so now you guys can help me. Okay, here, what kind of request it would be? A connection is going from browser to the web server. What kind of request it would be? Can somebody tell which protocol is it? Very, very simple question. It starts with the H. That is the clue. Nobody knows the answer. I'll write the second. Now, can somebody help me here? What is the other?
HTTP.
Okay, very good. Do you need HTTP or HTTPS? Which one you prefer? Just tell me, no problem. We can go ahead with HTTP or HTTPS. Which one you prefer? Okay, let it be HTTP one, and this would be HTTPS. Okay. So just giving what exactly is HTTP and HTTPS. These are basically web protocols. Okay. S is the secured version of the HTTP. HTTP is basically a plain text protocol. All the data sending from here to the this place goes in a plain text, so that somebody who is actually intercepting this request can see what is exactly moving through this channel. Okay, so HTTPS ensures that the data is encrypted with the help of a certificate, and it is safe from the hands of a third party. Okay, so from web API, what happens is basically these are okay. These are API calls. Okay, so whether it can be a REST or a SOAP based call. Okay, we can think that it's a REST based call. Okay, from so why this web application connects to the Azure AD is to ensure that the person who is actually logging in the case of a user signing in is the right user. Okay, all the identities are stored here. Okay, in the next phase, the web server web server basically sends the request to the web application to process. Okay, so suppose example like you are things on the cart. Okay, then you're going to uh, pay the amount. Okay, so this connection would be an HTTP based connection. Okay, one second. So the web server connects with the web application um, server via HTTP and HTTPS based connections. Okay, then the web server process the request and send it back to the web server, and the web page is send it back to the user. Okay, so now from this, one second, here also we need to provide a response. Response means the user is authenticated or not, those kind of details we can pass it. Okay, that is also REST based API you can think. Okay, then the next part is um, okay, so the web application, what happens is it connects to the database, right? To process the price, to fetch the price, all these things, it connects to the database. Okay, so the connection between the database and the web server happens through some protocols like JDBC or ODBC. Okay, this is a protocol, just a connection establishment protocol. Okay, now again the response has to be comes to the server. Response, it might be a binary response, like the it gives the data to the web server in terms of a binary or whatever the format that application server accepts. Then the next part is this database has to be encrypted, right, for a secure communication. That has to be initiated to the web server, and these database, sorry, database communicates with the key vault, and the request and response. One second, I can call response here. So basically the vault provides the key. Okay, the data of the key to the database to do the encryption and the decryption activities. So these all communication happens through also API based communication. So it might be a SOAP based API. We can put SOAP or an REST, whatever. For your familiarization, I'm putting SOAP. So there are two kinds of basically APIs. APIs can be developed two kinds, basically SOAP and the REST. That are the formats. Okay, then this is the complete structure and of a e-commerce website. It's a very high level architecture only. One second, what we can do is we can find, so we need to provide a response back to the users, right? uh, Once the application process the request which is provided by the sorry, application. Okay, I'm just copying it and pasting it. Okay. For the mobile also, this application is providing a response. Okay. So now we completed the diagrammatic representation of that e-commerce website in a high level architecture view. This is called the level 0 diagram, where we represent in a very high level of the architecture. Now in the second part, if we go into depth, um, we can make multiple steps, like the user is giving the inputs like the credential, then the credential is reaching here, then it is passed to the active directory to check. All these things can be expanded and make it into a very big diagram or a deep diagram, which is called the level 0 and the subsequent level 1, level 2 kind of diagrams. Now we are not going into that phase. That would be a bit time consuming, and you have to uh, practice this, then only you will understand. After getting into the industry only you will experience this, how this diagram signifies different scenarios. Now the thing is, now we completed the level 0 high level architecture diagram. Now just giving you some clues that each and every component which we used, okay, we have multiple properties of it. Okay, we can provide the name, we can make comments, add comments here. Okay, so if we click on this request, we can name it as http, then order flow. Like if I put this as the one, this is the first request going through. Okay, from here to the here, this is the second request, it is third request. That flow can be numbered with the help of these properties. Okay, and also we can add things like show boundary threads. Yes. Okay, that will help to assess us in terms of like what threats can be seen while we doing the reporting part. Okay, so just I'm making everything yes here so that we can see the maximum number of possible threats with these connections. Okay, then even the web, see the web application, if I click on the web application, we have the option like what kind of technology is it using. So I put like MBC5, that is a Microsoft based web application technology. Okay, uh, this is an Azure based application environment where it is hosted. Process XML, yes, it process XML. I'm just giving all these inputs to show you that we can see multiple threats related to this. Okay, this we put generic, any application, any kind of web server, let it be. This is also in Azure on cloud hosted application. Identity provider, as I mentioned, ADFS. Okay, sorry, it's Azure AD. Okay, then key vault, I'm clicking it. Okay, Azure key vault. Key vault firewall settings, allow access from all networks. I don't want to allow from all networks, but this is internal application, right? So selected networks only. Azure key vault audit logging enabled. So let it be like we are not enabling the audit log. Okay, here, because we need to see what kind of threat it would be if the auditing is not enabled, like if the logs are not stored. Okay, authentication to key vault, that is true. I can mention here as like principal and certificate. This database is having a certificate, and that is how this Azure key vault is, or the database is authenticated to the key vault. Okay, so yes, now I finished almost everything. Let it be yes. Now the crucial part next is the generation of the reports. So once we completed this diagram, the next step is the generating the reports. Okay, then only we come to know that what kind of threats this application poses. Okay, this architecture poses. Okay, so what we developed is literally from the design input, right? Okay, our architect or somebody said to me, go and do a threat modeling for a e-commerce website. He just gave me that much only in the design phase. Then a high level view, he gave me the input. Based on that, I created this thing. Now I am going to generate a report. Okay, now the next thing is what we have to do is go to the report section, press on this create full report. Okay, a pop-up came, and what I have to do is check this all things like possible mitigation. So it will show us the recommendation that what can be done, and the SDL phase, where in which phase which it can be mitigated. Okay, I'm just clicking generate report. Okay, so the next step, it will ask you where can we save the report. I'm just saving it here. Okay, um, em, okay, ecom. Okay, I just saved the report. It is generating the report meanwhile. Okay, so now what you see is the completed threat modeling report. Okay, so we can see here this tool has basically analyzed our architecture, and it has plotted the vulnerabilities. Okay, so let's see. As I mentioned, this architecture, this tool basically decompose the architecture, and it possibly it finds the possible threats in each and every assets or the interactions basically. Okay, so you can see here that from our database to the web application server, we have a binary connection, binary string. Okay, so there is a risk related to that. That is what they have highlighted this part. And the risk they mentioned, or the threat they mentioned, is basically an adversary, basically an attacker, can reverse weakly encrypted or hashed content. Okay, so as I mentioned, the data which is stored in the database is in encrypted format, and once we pass this data to the web application server, there might be a chance that an internal or an external attacker who gets the access to this connection can actually decrypt the weakly encrypted or hashed contents if we are using a weakly a weak encryption or a weak hashing algorithm. Okay, so they mentioned the priority as high. Okay, then the next part is an adversary may gain access to sensitive data from log files. As I mentioned, we have not enabled the logging part, right? So logging has to be enabled, otherwise, and the logs has to be protected. Otherwise, the adversary, though, the attacker can access the sensitive data from the logs. Okay. Okay. Then this is kind of a generic one where if some error messages are um, popping up, or we are displaying some error messages, then we have to restrict the information which we are representing. Okay, then we'll go to some interesting threats. Okay, deny malicious act and remove attack. Okay, reputation issues and can spoof the target web application due to okay, let's start from here. This one, an attacker can spoof the target web application due to insecure TLS configuration. Okay, so here the connection is an HTTP connection, right? So here, if it is not a HTTPS based connection, the attacker can do a middle man in the middle attack. Okay, that is what mentioned here. Then attacker can spoof the database and gain access to the web application. Okay, that is one kind of attack. Then SQL injection can be performed. Okay, coming to this part, HTTPS, sorry, HTT, this is something wrong which I put, HTTPS basically. Okay, here we have to uh, have different kinds of role-based access control. Otherwise, poor access control may lead to unauthorized access. Okay, like that, we see a lot of vulnerabilities like interaction HTTP. Here, HTTP-based connection is going. Okay, so threats related to that are popped up. See, this application can analyze each and every component, and it can show n number of vulnerabilities attached to the application, the architecture. So what happens is, in the next phase, once we completed the threat modeling, we do the prioritization check, as I mentioned in the PPT, right? We do the we now we first asset identification is done. Okay, then attack surface analysis is done. Attack vectors we identified. Now we analyze the attacks, basically the threats. Okay, then we prioritizing the threat. While we prepare a report, we prioritize now how many number of high vulnerabilities are there. The next part is, based on that threats, we recommend them the controls. Like as I mentioned, we have to use here HTTPS based connection. Then here we have to have a strong encryption algorithm. Okay, otherwise reverse engineering can be can happen and disclose the data. All these kind of mitigations, we will write it in a document and share it to the or present it to the development team, so that they can take action in the next phase, that is basically while they performing the development, right? The diagram, while they performing the development, they can consider those recommendations and they can do, so that once they do the static analysis or the dynamic analysis of the application, basically again security testing, those threats can be eliminated. They can only focus on the threats related to the code and the running environment. Okay, this is how a threat modeling is performed in the industry. So I appreciate all of you to practice this kind of exercise while you get some time, because this will really helpful in terms of enhancing your knowledge in terms of the architecture, how an application works. You can try google it, like how which authentication protocols used. You just plot it down in a very high level, try to google it, how to connections are established. That's how you deep dive into architecture, and in the future, once you go for an interview, you will able to perform from the other candidates and succeed your aspiration as a security enthusiast or a professional in the industry. So thank you everyone for listening to this session and making me to work on it. Uh, if you have any doubt, please raise it. Otherwise, I am good to complete this session. Hope everybody understand this.
Thank you, Mr. Najeeb, for such a thought-provoking session. I'm sure everyone present here really valued the knowledge you shared and are the most appreciative of this session. So now proceeding further, the session is open for the questions and discussion. So as your great presentation has raised the level of curiosity of our students. So if anyone has any queries and questions, please feel free to ask. And students may type their questions in the chat boxes too, they can use. Students, if there is connectivity issues, sir, as today few of the students reported that they have some connectivity issues. That's why they'll type their questions in the chat box. Kindly check
No
that.
problem. Thanks, Ashif, for the answer. I have not seen this. Thanks. It's a right answer only. Correct.
Okay. So
HTTP.
on,
Okay.
yeah,
Good. You guys are very good. You know the concept. You know the logic.
yeah. So thank you, sir. On this note, we have entered the final moments of our session, where I feel privileged to propose a vote of thanks. First of all, I would like to thank our Department of CSE, AI and ML, and Cybersecurity and Futurance Technologies to conduct a wonderful event of Industry Connect, where our students with faculty members are fortunate to connect with the eminent industry experts of various domains. On behalf of the Department of Computer Science and Engineering of Jain, deemed to be university, and all the students, I extend a very hearty vote of thanks to Mr. Nadeem Najeeb to accept our invitation and for refurbishing our students with the best possible and upgraded education. I must mention a deep sense of appreciation to our beloved HOD, Dr. V. Vivek, for his constant support and motivation. I sincerely thank our team of very motivated and hardworking faculty members to join the session. And finally, I would like to thank our students for paying their valuable attention. And once again, I would like to thank everyone for joining the session. Thank you. Thanks a lot.